Okay, I turn off my video to reduce the size of the file. Structures in C++. On the slide, you may see the general diagram that shows you all the data types. The data types in C++ can be divided into two main groups: basic types, built-in types, and derived types. Basic types, you can use it without any additional declarations. Examples of basic types are int, double, float, char, and its modifications: short int, long, double, and so on. And there are a group of derived types that can be defined by programmer. We already working with pointers, references. When we need to pass their parameters to the functions, we use references. Also, we worked with arrays. When we need to declare a group of variables with the same name and different indexes for each variable. And the next derived type that we consider today is structure. After that, on the next lessons in May, we will consider classes in C++. What is a structure? Very often in real life, in real applied problems, we have a deal with a data type of variables with different data types. But all of these variables describe one information element. For example, imagine that we are going to write a program that should process some information about students or any other persons. One person has a name, age, position. If we are talking about the students, each student has the number of the group, the course, the marks on the exams, and so on. A lot of attributes that correspond to one information object, person. In this situation, the language suggests a special data type called structure. Using structure, we can unite these different variables of different data types in one information object. So a more or less formal definition of a structure is written here. A structure is a collection of one or more variables, possibly of different types, grouped together under a single name for convenient handling. The main points of this definition are that structure is a collection of one or more variables. Usually it's not one, of course, 2, 3 different variables of different data types. Because you already know how to unite, how to collect variables of one data type under a single name. To do it, we can use an array. From this point of view, array is a collection of variables, but this variable must have one data type. A structure is a collection of variables of different data types. Structures help to organize complicated data, particularly in large programs, because they permit a group of related variables to be treated as a unit instead of as separate entities. Again, if we come back to the example of a program when we need to process the data related to one person, of course, it's better to operate with one information object that consists of name, age, position, name of the group, and so on, instead of different variables, name, age, and position. The general form of structure declaration is presented here. You should write a keyword struct. After that, optional parameter, but usually we write it, name of the type. Then in figure brackets, we should write the list of the members of the structures. And after the close figure bracket, one more optional parameter, name of the variable. Struct is a keyword. Type name is the name of a new type that corresponds to the new information object structure. Var name is optional and usually in 99% of cases it's omitted. But var name is the name of one particular variable of this new data type. List of members is a list of declarations of variables, possibly of different types. Well, this is a general form of declaration. Let's consider one particular example. Suppose that our program should process information about some geometric objects. And let's consider one of the simplest geometric objects, like point on a plane. If we consider a point, this point can be described by means of two integer numbers, coordinates of the point, x and y. That's why I can create the structure point that has two members, data members, X and Y of the type integer. Let me copy this declaration into Visual Studio. Struct point and two data members of this structure, X coordinate and Y coordinate. Let me repeat that the variables named in a structure are called members of this structure. A structure member and an ordinary non-member variable can have the same name without any conflicts. Moreover, the same member names may occur in different structure. Although, as a matter of style, one would normally use the same names only for closely related objects. A struct declaration defines a new type. So the declaration of the structure can be considered as a declaration of a new data type with a name point. And the right brace that terminates the list of the members may be followed by a list of variables, just as for any basic type. So this line is syntactically analogous to this line. Here int is a built-in type and struct with members are either derived type structure. A structure declaration that is not followed by a list of variables reserves no storage. It just describes the template of the structure or shape of this structure. No variables of the data type point is declared if we just declare the structure point. In the example number 2, these two lines define variables which are structures of a type point. Okay, let me show you in Visual Studio. So the structure point, and after that, I can use point as a name of the data type. So point A means that the variable A now has a data type point. This program is correct, and if I try to compile it, okay, if I try to compile it, compiler tells me succeeded. This program does nothing, just it's declaring the structure A of a type point. Of course, this declaration, it should be placed before using of the structure. If I put this declaration after the main, compiler can output a mistake. Usually it's placed before. Well, after that, I can use a point as a name of a data type, and I can declare a variables of this data type. So A, B, and C are the variables of the type point. Okay. Initialization of the structure. Structure can be initialized by following its definition with a list of initializers. Each initializer should be a constant expression, and the order of initializers corresponds to the order of members. For example, if I declare such point, it means that the first member field will equal to 320, and the second field, the second member, will equal to 200. This value will correspond to X. This value will correspond to Y. The order of the members is significant. Also, structures may be initialized by assignment or by calling a function that returns a structure of a right type. Okay, now you know how to declare a structure, how to initialize the values of the members of the structure. But how to operate with the structure, how to get access to the members. A member of particular structure is referred to in an expression by a construction of the following form: structure name, point, member name. This operator point, connects the name of the structure and the name of the member. If the structure point has two members, X and Y, I can get access to this member in the following form: pt.x and pt.y. Let me copy this example here and let me use our identifier max pt. Let me run the program and we should see on the screen two numbers, 320 and 200. Yes, as output. Well, and also Visual Studio helps you in this case. If you type the name of the variable that has a data type of structure, and type a point, Visual Studio outputs you possible suggestions, the list of the members of this structure, a point x, a point, and possible variants y. Moreover, if you type here some comment, for example, x coordinate and y coordinate, and here a comment point, or maybe a two-dimensional point. Let me write here comment two-dimensional point. Now, see, let's see, if you move pointer of a mouse here at a type point, Visual Studio outputs you your comment that you write here, my comment, two-dimensional point, yeah. And also when you type, for example, b point x, you will see here a comment. You will see here a comment that you type here. Oh, of course, it's not x coordinate, but y coordinate. Yeah. You will see here a comment that helps you to understand what is the meaning of this structure and what is the meaning of this member. Okay, let's assign some values to the member fields of a structure A and of a structure B. Well, here I want to show one more example how to work with the structures, how to get access to the structure members. This formula computes the distance from the origin, the point with coordinates 0.0, to the point PT, double dist, that computes the distance from the origin to a given point. Okay, well, but here in the presentation it's written PT. Let me use here, for example, AX, AY, and the dist will be the distance from the origin to the point A. Let's output this distance to the screen. And we will see some value. For example, if I assign here just for example 10 and 0, the distance should be 10. Yes, we will see 10. Do you have any questions about structures? Okay. Now let's move to the next slide. In C++, we can also define nested structures. I can use one structure as a part of another structure. For example, if we discuss about geometric objects, I can represent a rectangle as a pair of points that denote the diagonally opposite corners. So any rectangle can be represented as a points, 2 points that corresponds to diagonally opposite corners of this rectangle. In this case, I can introduce the structure rect that corresponds to rectangle, and the members of these two structure are 2 points. Point number 1 and point number 2. Let's do it. Let me write here some short comment. Rectangle. This point. Let it be the point that corresponds to the left upper corner of the rectangle. Left upper point, and this point, let it be right lower point. 2 points. And now I can declare their structure of a type rect. And the members of this structure will be another structures. I can assign R point number 1, or let it be just left and right for simplicity. R point left equals to A, and R point right equals to B. I assign previously defined point A and B as their left and right points of the rectangle R. Let's check, let's compile this program, and we will see that the program is correct. How to get access, in this case, to the member fields? In this case, I can use 2 points. First point gives us access to the member field of the type point, and the next point gives us access to the member field of the type integer. Here, this line refers to the x coordinate of the point number 1, of the variable screen. In my example, in Visual Studio, I can change the coordinates on the following way. R point, for example, right, and after that I can change the, for example, value y assigned to 20. As far as structures are nested, I can get access to the member fields using 2 points. Okay. Let's discuss about the relation of pointers and structures. If a large structure is to be passed into a function, it's generally more efficient to pass a pointer to the structure than a copy to the whole structure. Structure pointer are just like pointers to ordinary variables. What is a general form of declaration of a pointer? I should write the data type, then I should write a sign star and name of the variable. Now in this example, or let me just delete one sign P here. P is a pointer to the structure of the type point. If P points to a structure, then star P in the main program is a structure to which this pointer points. And this construction, star P in brackets point X, star P in brackets point Y, are the members of this structure. Here is an example how we can get access to the structure origin using a pointer P to the structure. Again, let me copy this example into Visual Studio and let me run it. Let's declare a structure origin with their initial values of X and Y equals to 0. Then I declare a pointer P and I assign to P the address of origin. And now I get access to the values of the member structure of the structure origin using pointer P and output these values to the screen. It's better to, of course, it's better to put here a space and the end of line. The end of line in the end of our output. Yes, you will see that the origin is 0.0. Again, pay your attention that I get access to the structure origin using a pointer that points to the structure, but not the name, the real name of this structure, origin. Pointers to structures are so frequently used that an alternative notation is provided for shortness. If P is a pointer to a structure, then I can get access to the member of the structure not using this construction star P point X, but the special operator arrow. This arrow consists of two signs, minus and less than, comparison sign. But using this sign, I can get access to particular member of a structure to which the pointer P points. So we could write Cout origin P arrow X, P arrow Y. Both signs point and arrow associated from left to right. So if we have declared two rectangles, rectangle R and the pointer to rectangle that points to R, then these four expressions are equivalent. R point P to 1 point X, pointer to R arrow, then point number 1 X, and so on. So these four lines are equivalent. Well, let me show using the operator star, not star, arrow here in Visual Studio. First of all, if you type star and P and you press the point, Visual Studio expands you this list of the members, and you can select a particular member from this list. But the same happens if you will use a pointer. But if you just type a point after a pointer, it will be a mistake. But if after the pointer to the structure you type the arrow, Visual Studio expands you the list of the members of the structure. And you can select a particular member from this list. So this notation is more simple in comparison to this one. And also it stresses that P is a pointer to a structure. And if I run this program, I will see the same result. So the better notation, if we use a pointer to a structure, is to use arrow. Well, let's come back to my presentation. And now let's discuss about the structures and functions. If we just declare the structure, the only legal operations on a structure are copying it or assigning to it as a unit or taking its addresses with the special operator ampersand, getting the address, or accessing its members. Copy and assignment include passing arguments to functions and returning values from a functions as well. And also structures may not be compared. A structure may be initialized by a list of constant members values and by assignment. Let's investigate structures by writing some functions to manipulate points and rectangles. There are several approaches. Pass components separately, pass an entire structure, and pass a pointer or reference to a structure. Each approach has its own advantages and disadvantages. Let's consider some features of these approaches. First example, let's consider the function that makes a point. Suppose that I pass to this function two coordinates, x and y, and this function should returns a point with these coordinates. How to do it? I declare a temporary structure point inside this function, assign the values, and return this temporary structure into the main function. Pay attention that there is no conflict between argument names and the member names. Here arguments have the names x and y. The structure members have the same names, x and y, but no conflicts. Indeed, the reuse of the names stresses the relationship between these parameters and this member, this parameter and this member. Let's check this function in Visual Studio. So I write a function makePoint, and now I want to use it to make a point A. How to do it? A equals to makePoint and two parameters x and y. The function makePoint returns a structure that I assign to a variable a. The same I can do for variable b, for the structure b equals to makePoint 20 and 20. Let's compile this program. Let's check it. Yes, it's correct. Well, another example that I want to consider with you. Let's move this computation into a function. This formula allows us to compute a distance from the origin to a given point. Let's write it in the form of the function. What will be the input parameter of a function? The input parameter will be a structure that corresponds to a point to which we want to compute a distance. And the output parameter of the function will be a distance computed to this point. So the output parameter will have the type double. Let's call this function distance, dist. And the input parameter, it will be a structure of a type point, point A. Okay, let me copy. Let's move these two lines here. Again, what is the goal of this function? The goal of this function is to compute the distance from the origin to a given point. This point is passed to this function as a parameter. Here we compute a distance to this point and return this distance as a result. Let's try to use this function. Now the dist is a function and I must pass here a parameter, the name of a point. Now I output the distance from the origin to a point A. Distance A equals to 14 and something. For example, if I want to compute to a distance from the origin to point B, I should call to distance B. And I will see the distance B that is twice more than the distance from the origin to a point A. Okay. Well, let's move to the next slide. Now, let's consider two examples. Some simple function that implements some simple arithmetic of points. For example, I want to compute point plus point. How to do it? These are two examples of this function. Point number 1 plus point number 2. I compute the coordinates. I add the x coordinate to x coordinate of the point number 1. I add y coordinate of the point number 2 to y coordinate of the point number 1 and return it as a result. Let's check this function in Visual Studio. And now let me I comment all of these previously written code. And now let me compute the point C as a sum of 2 points, A and B. And let's output the coordinates of the point C to the screen. C equals to C point X and C point Y. Let's check how it looks to the screen. We will see 30 and 30. Yes, it's correct because I add the point A plus B as 10, 10 plus 20, 20. But again, pay attention that here I pass 2 parameters, P1 and P2, and I add coordinates of P2 into P1. And if I output the value of the first parameter, let's do it. Let's output the coordinates of point number 1. Let's output the coordinates of point number 1 here inside the function. And let me output the coordinates of point A outside of the function, after the function. And we will see that the point number 1 is changed, but the point A is not. Point number 1 is 30, 30, and yes, it's correct because it's a result, but the point number A is not changed. Why? The answer is as follows. I pass here the first parameter as ordinary variable. I pass this parameter by value. It means that not actual parameter A is passed to the function at point, but a copy of A will be passed. And all of the actions that I carry out here with the first parameter will be done on copy of actual parameter. Actual parameter is not changed. How to change this situation? It's very simple. It's very simple to change this situation. I can pass a reference as the first parameter. In this case, the logic of this another function at point will be different. First function adds points P1 and P2 and returns the result, new point that equals to P1 plus P2. But the parameters P1 and P2 will be without any changes. This another implementation. It adds point number 1, or sorry, it adds point number 2 to the point number 1, and the value of the point number 1 will be changed because I pass here a reference to the point number 1. In this case, the type of the result may be void. I don't need to pass any result from the function because this result is a first point that will be changed. Let's check it in Visual Studio. Let me write here a reference sign and let's change it to void. After this, I just can call this function as add point AB. It means that I add B to A. And the result will be the same, 30 and 30, or what happens? I try to output the variable C. I should comment it because I changed the value of the variable A. Yes, we will see that the value of A will be 30 and 30. And the value of P1 inside the function will be 30 and 32. Again, this happens because I pass a reference into a function as a parameter. Well, do you have any questions about such data type as a structure? Well, if you don't have any questions, let's finish our lesson. I stop sharing my screen. I stop recording.